Every single morning, millions of people around the world participate in a massive coordinated chemical experiment. Whether it is a steaming mug of coffee or a delicate cup of tea, we are all seeking the same thing, a tiny molecule called caffeine. But have you ever wondered how this simple substance actually works? It is more than just a morning ritual. It is a molecular hijack of your brain's natural systems. To understand caffeine, we first have to meet a molecule called adenosine. Throughout the day, adenosine builds up in your brain, acting like a biological timer that tells your body it is time to rest. When adenosine plugs into its specific receptors, think of them as specialized locks. It slows down nerve cell activity and makes you feel drowsy. But here's where the chemistry gets clever. Caffeine is a master of disguise. Its molecular structure is strikingly similar to adenosine. Because of this, caffeine can float into those same receptors and plug the lock. But it does not turn the key. By occupying the space, it prevents the real adenosine from doing its job. So caffeine does not actually give you new energy, it just stops you from feeling the exhaustion you have already built up. It is like putting a block behind a brake pedal. The car is still moving, but you have effectively disabled the mechanism that is trying to slow it down. But what happens to all those flavors we love? Before it reaches your cup, the coffee bean is just a hard, flavorless green seed. The magic happens in the roaster. When we apply heat, we trigger a series of complex chemical transformations known as thermal degradation. The most famous of these is the Maillard reaction, the same chemistry that browns a steak or toasts bread. During this process, sugars and amino acids inside the bean break apart and recombine, creating over 800 different aromatic compounds. Some provide that familiar chocolatey smell, while others offer fruity or nutty notes. Once roasted, the chemistry moves to the brew. Hot water acts as a solvent, pulling out the caffeine and oils through extraction. However, timing is everything. Extract too little, and your coffee is sour. Extract too much, and you pull out heavy, bitter tannins that ruin the experience. It is a delicate balance of temperature and time. But is coffee the only place we find this powerful molecule? While coffee is the king of caffeine, it is far from the only source. Did you know that tea leaves actually contain more caffeine by weight than coffee beans? However, because we use fewer tea leaves per cup, the final drink usually has about half the punch. Then there is chocolate, which contains a smaller amount of caffeine alongside a related molecule called theobromine, which provides a much gentler, longer-lasting lift. Once caffeine enters your bloodstream, the effects go far beyond just blocking sleep. It triggers the release of adrenaline, increasing your heart rate and opening up your airways. It even boosts your metabolism by encouraging the body to burn fatty acids for fuel. But can you have too much of a good thing? Every person metabolizes caffeine at a different rate. For some, it lingers for hours, leading to jitters and a racing heart. This is because the liver has to work hard to break the molecule down into smaller parts. Understanding your own limits is the key to enjoying this ancient chemical boost without the crash. Caffeine is truly a remarkable molecule, a bridge between the world of plants and the complex chemistry of the human brain. The next time you take a sip of your favorite brew, remember the molecular masquerade happening inside your head. If you enjoyed this deep dive into everyday chemistry, make sure to subscribe for more. Thanks for watching.